Hey everybody, so today I just want to do a quick video on how we can incorporate Rust code into LabVIEW. So for those of you who do not know what Rust is, and I don't want this to necessarily be like an intro to Rust video, but it's basically a system level programming language, so similar to like your C, C++, but a lot better memory safety, right? You can't there's a lot better just control and memory management is kind of handled for you, similar to LabVIEW. Explicit data typing, right? So you can't, it's not like Python where everything's really loosely typed. So yeah, it's a programming language, and as I've started playing with it some, I've actually been really impressed with some of the stuff you can do with it. That it's pretty low level, but it's also at the same time very high level. So there's a lot of stuff that you can do that's just very, call a function and it does something, but at the same time you can also go down very deep and control things at an extremely low level. And because of that, right, there's a lot of things that Rust can do that LabVIEW just can't do that well or requires integration with other things. So just wanted to kind of demo how you can basically write some code in Rust and then incorporate that into LabVIEW. So first, to start off, I'm using VS Code. You don't necessarily have to use VS Code. This is just my preferred GUI. You will need to install Rust C. You can download that off the internet. And then in VS Code, you will need to install the Rust Analyzer. But once you have that set up, you are ready to go. So to start off, I'm just going to open a terminal, and I'm just going to, go into my documents. Sweet. So next thing, I'm going to use this command cargo. So cargo is in Rust how you do all sorts of different things. So you're going to use cargo for setting up a new Rust project, which is what I'm doing right here. You can use cargo for installing applications. You can use cargo for adding packages. You can use cargo to run your code, and you also use cargo to build your code. So if you're wanting to program in Rust, you will have to get familiar with cargo, but it's actually super simple, and there's really just a couple commands you need to learn, and it'll do pretty much whatever you need to. So I'm going to use this cargo new command to set up a new project, and I'm just going to call this demo library. Sweet. So I created my package. I'm going to move into that new folder I just created, and then I'm going to just open it up in VS Code. Sweet. So over here, I've got it generated my project. So I get a TOML file, and these TOML files are really important in Rust. Here's where I actually define details about my package, and I can also include dependencies. So the different libraries that I'm using can go here. And then, when I build this package, it will pull information from, or when I build my code, right, it'll pull this information here. And you get this cargo log file. This is automatically generated. You don't really want to mess with that, and it actually warns you, don't manually be editing this. And you also get a source folder that includes this main RS, and it gives you a little hello world example. We don't actually need this, so we're actually not going to use main RS for creating a library. Like what we're going to do is create a Rust DLL that we can call in LabVIEW. Your main.rs is going to be your top level, a function that is built into like an exe. Some sort of app. It doesn't even have to be an exe either. Rust is really cross-platform, so it doesn't have to be an exe, right? This could run on Linux, Mac, etc., depending on what you're targeting. But in this case, we could just delete main RS and we would be totally fine. It wouldn't matter at all. But in this case, I'll just show you it so we can see how you can also build just a Rust application and use it to work with LabVIEW. And you can return data through like standard in and standard error and stuff, but not really wanting to go into that. That's not really what I was trying to highlight, but I'll just show you. So I'll just change this. So basically when you run this, it's just going to output on standard in, thanks for watching Canon Controls. So nothing crazy. So what we're really going to want to do though is under our source folder, we're going to want to create a new file, and we're going to name this lib.rs. So when we're wanting to create a library to be called in other languages, we're going to put that in lib.rs. And yeah, next we can actually add our code. So the very first thing I'm going to do is use this command called no mangle. So basically what this does is it makes sure that if I've named a function something specific in this lib.rs, when it's getting compiled, it just prevents the name from getting mangled. So you could end up with like a slightly different name when you're calling it in other languages. So this just forces it to retain the name that I've given it. Next, we need to define this as a public function to be externally called. And we're going to use this C annotation basically to define that we're using the C calling convention, which is how we're going to call this library, and fn to define a function, and we're going to just call this function add numbers, and we're going to define the inputs. So we're going to have an A, there's going to be an I32, and a B that is also going to be an I32. So we can take these two numbers in. Those are our two inputs. And then we are going to define what the output is, an I32. From there, we can define our function. So all we're going to do is A plus B. Right, so we've defined our function. You're taking in two inputs. A is an I32, B is an I32, and we're going to output an I32. And all this function does is take A plus B, and there we go. So that's one function in our library. We can add as many as we want. So just a demo, I'm just going to add one more and call this subtract numbers, and just change this so it will subtract. And you can add things, they can be as simple or as complex as you want. You can include, different libraries and all sorts of stuff. But yeah, basically that is our library we're making for this demo. So we've got a add numbers function and a subtract numbers function. Now, before we actually build this, there's just one thing we need to do, is we need to go into our TOML file, and we need to add one more section. So we're going to add a lib section, and this is just where we're going to pass in parameters about our library. And this actually lets it know that it needs to build a library of our lib.rs as well. So we need to add first just a section, which is the name. So this is going to be the name of the DLL we're going to build. So let's just call it demo DLL. And last, we need to use this create type parameter. And we're going to define this as cdylib. So this is just going to define what we're actually building this as. So this is going to be basically a C DLL that we want to build. So let's save everything. And that's pretty much it. So here now we can build our application. So like I said, you're going to use cargo for this. So cargo build -- release. Now you don't necessarily have to do the -- release. If you don't, you can build a debug version and a release version, right? The release version just doesn't have the debugging capabilities built into it, so it's a little smaller and a little faster than the debug, but yeah. So let's build this. Take just a second. And we're finished. So we've got our target built really quickly, right? Took 3.8 seconds. So now we can go check on what was built. So let's go here. So I called it, demo library. There we go. Sweet. So you can see here, this looks just like we had in VS Code. We've got our TOML, our lock, our sources in here. And here we've got our target. When we built, it actually created this target folder. And here in our release, we have our actual builds. So you can see we've got our exe that was built from our main.rs. And then here is our DLL that's built from our lib.rs. So just to show the exe running, yeah, I'm just gonna put that in here, run it, and yeah, you get that output that says thanks for watching Cat and Controls. So yeah, just showing that. Didn't really want to highlight that, but what I do want to highlight is how we can now call that library in LabVIEW. So we're going to use the call library function node, and if you don't know where that is, if you go to connectivity and go to libraries and executables, it's right there, call library function node. We can double click on this and open it up. So we need to pass in our DLL, whoops. So I'm just gonna drag it in. You also can use the file explorer and find it. So I've dropped this in and I now can see my two functions I created. So let's use the add numbers function. And we want to make sure its calling convention is set to C because that's how we built it, which is the default. Lastly, we just need to define some parameters. So our return type, we need to set up to be numeric. And if you remember in our code, let me open librs, right? We called this out as an I32. So we want to make sure that we are using the same data types. So assigned 32-bit integer is an I32. Next, we just need to add our two inputs. I can also add a name here, so I can call it like sum, all right? And let's go call this A, and make sure it's a numeric, sign 32, and call this B, and it's a numeric, sign 32. So we've got that set up, and I'm gonna just change the name format so you can see. So we've got an A and a B, and we want to show our sum. So it is also going to output our A and our B. These are just the numbers that were passed in. But yeah, let's go to the front panel. So let's set our A to something and our B to something. And we output, we get a sum of 6. So works just great, right? We also can create additional functions, but let's switch this one to the subtract. And everything's set up the same in subtract, so I don't actually need to change anything. Just this is no longer actually the sum, but it would be the difference. So let's run that. So 4 minus 2 is 2. So it works. But yeah, that would basically be how you can build a DLL in Rust, using Rust tools, using Rust libraries that are available that you can then work with in LabVIEW. So you can kind of take advantage of both programming languages, and you can use LabVIEW for what it's good at. For example, right, creating a user interface in Rust is super complicated. I mean, it's much easier actually to just host a web server and then build your, interface as like some sort of, in some other sort of language, could be like React, could be whatever, right? Yeah, building user interfaces in LabVIEW is super easy, right? I just drag and drop a few things. So this way you can take Rust, use it for what it's good at, build functions that you can use in LabVIEW, and then, be able to build your system and your GUI and whatnot in LabVIEW. So that would be how you can just build a DLL in Rust and call it in LabVIEW. Hey, so just wanted to show one other example. So a little bit more complex than just adding numbers, right? This is leveraging the ability of Rust to convert a TOML file to a JSON file. So LabVIEW doesn't really have great TOML support. There's a few different libraries out there that the community has put together that implement portions of TOML capabilities, but there's really not great TOML support in LabVIEW. Whereas there is lots of support for JSON. Like the JDP Science library is fantastic, works great, and JKI also has one, and there's a few other different JSON libraries out there. So, for example, we might want to take a TOML file and convert it to JSON so we can work with it a little bit easier. So this is set up similarly, where we've got this TOML to JSON file, and we're using just this TOML to JSON function. So we can pass in basically the string, whether we want it pretty printed or not, and the length of the string. So we can do that. And then it will call just this function here to actually allocate the memory. And then once we're done, we're just going to use this C-string free memory to free up that memory that we no longer need. So this will take that TOML, convert it to JSON, let us view it in LabVIEW, and interact with it in LabVIEW, but all the code is actually written in Rust. We're just calling that in LabVIEW. So let's run this, and you can see we have this example TOML document, and from that we get JSON. So yeah, that would be how you can, just another example of how you can build code in Rust that for things that Rust is really, really good at, but then incorporate that into your LabVIEW projects and use LabVIEW for what it's really, really good at. So yeah, thanks for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.